Now here I'll discuss TPC 11, that's a dearrangement theorem. Now let's take an example to understand what is this theorem. Suppose there are two letters and two envelopes, and these envelopes are corresponding envelopes. Suppose this letter the correct position of this letter, correct envelope for this letter is this, right? And correct letter for this envelope is this. So basically this letter should go into this envelope and this letter should go into this envelope. So number of ways, if we have to just answer this question, that number of ways in which we can place these two letters in their corresponding envelopes, in their respective envelopes, then answer is one way. And or we can say in how many ways we can do our job right, placing the letters in their corresponding envelopes, then answer is one. This letter should go into this envelope, this letter should go into this envelope, the one way. If my question is in how many ways we can do it wrong, in how many ways we can place letters in envelopes so that both the letters should not go into their corresponding envelopes, both the letters should go in wrong envelopes. So that is possible when this letter goes to this envelope and this letter goes to this envelope. And again the answer is one way to place both the letters in wrong envelope, right? Now same thing can be done using dearrangement theorem. Wrong way, both wrong. So we have found the answer both wrong, both letters go into wrong envelope in one way. Now dearrangement theorem says that if we have suppose R objects and there are, or let's take an example, there are n objects and there are n places for n objects to be placed there. So these are the corresponding positions for these n objects, and then it is marked that this is object 1 should go into this first position, object 2 should go into the second position. So basically for every object the corresponding position is marked, corresponding holder container is marked, that the third will go in third, fourth will go in fourth, right? So that if we have to place all of them correct, the answer is 1. Now if dearrangement theorem says that if we have to find number of ways to place these n objects in n of these places, their corresponding places, then in how many ways we can do that, in how many ways we can place them so that no object should go to its corresponding container, no object should be placed in its corresponding placeholder, all objects should go into wrong placeholders. So the concept is, the idea is that all go wrong, none of them is in its corresponding position. So the according to dearrangement theorem, it is n factorial, all go wrong is n factorial, 1 minus 1 by 2 factorial. So it's an alternate plus minus signs, and you keep on increasing the numbers in denominator. 2 factorial, 3 factorial, alternate plus minus sign, 4 factorial, plus minus goes on till the last term is 1 by n factorial. If you want to see the sign, you can say minus 1 to the power n. If it is even number, if it is n is even, then sign is minus sign. So you can say minus 1 minus n minus 1, right? But I don't think you need to remember this because you have to go in alternate plus minus manner, right? Now let's come back to this example. Sorry, there's a mistake I've done here. It is n factorial, 1 minus 1 by 1 factorial. I missed out this term. 1 by 2 factorial minus 1 by 3 factorial goes on plus minus. So finally the power should be n, or minus 1 the power should be n, right? So I missed out the 1 factorial term. So 1 से start करेंगे, or you can say 0 factorial, 1 by 0 factorial. So either it is 1 or 1 by 0 factorial, minus 1 factorial goes on. This is the dearrangement theorem, to place n objects in n corresponding positions so that no object is placed in its corresponding position. N objects, n places, none of them is placed in its corresponding position. So in this case, if we would have applied formula 2 factorial, 1 minus 1 by 1 factorial plus 1 by 2 factorial, you would have got the answer 1, right? You can check answer is 1. Answer is 1. Now let's take an example of 3 objects. There are 3 letters, 3 envelopes, number of ways to place all correct. If you have to place three letters in three envelopes, in how many ways we can place them so that all three letters go to their corresponding envelopes? All should be correct. The answer is 1. If you have to answer question 1 correct, sorry, all correct, let's reduce 2 correct and 1 wrong. So it is all correct means 0 wrong, 2 correct, 1 wrong. So it means, suppose if you say these two letters are placed in their corresponding envelopes and this goes wrong, not possible. How is this possible? Because if two letters are placed in their corresponding envelopes, one letter cannot be placed in the wrong envelope because the only leftover envelope is the corresponding envelope. So it has to go right, right? Or we can say, let's do the wrong one first. If I say I'll put this wrong, I'll put this letter in this envelope, so it goes wrong, then it means I have utilized the envelope of this letter. So there's no option this letter has to take some other envelope. So either it will take this envelope or it will take this envelope. So at least two will go wrong, right? One wrong is not possible. So this is not possible. We say 1 correct, 2 wrong. Yes, possible. We choose one letter that will go in correct envelope, 3C1. Out of 3, which choose the one which will go correct, place that in one way in the current envelope, and then the two are left, two objects are left, and we have to place both of them in wrong. So we can apply, let me write here, 1 correct, 2 wrong. 1 correct, we select correct one out of 3, place it correct, and then now two letters, two envelopes are left over, and we have to make sure both of them should go wrong. 2 go wrong means both go wrong. We apply dearrangement, 2 factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial, right? Now third case can be all 3 wrong. 3 wrong, we can say 0 correct, 3 wrong, same as all wrong. All wrong means dearrangement theorem, 3 factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. On simplification, answer is 6. It is half minus 1 by 6 into 6. Answer is 3. Answer is 2. Sorry. All go wrong. Answer is 2. Yes. And if you take example of 4 letters, it's the same thing. If we have to say all correct, correct, wrong, all correct, 4 correct, 0 wrong is one way. 3 correct, 1 wrong, we saw it is not possible. 1 wrong is not possible. 2 correct, 2 wrong. 2 correct means select 2 which will go correct and we place them in correct way in one way, and 2 go wrong, dearrangement. One correct, 3 wrong. Select one that will be go correct, that will be placed correct, and remaining 3 should go wrong, dearrangement. Zero correct, all wrong, straight away dearrangement. Sorry, 1 factorial. 1 minus 1 by 1 factorial plus 1 by 2 factorial. 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. All go wrong. Minus 1 by 3 factorial plus 1 by 4 factorial. Right? So based on what we have to answer, how many wrong and how many right we have to find answer, we'll do correspondingly. So you can just go through the illustrations based on this TPC, that is like 54, 55. That's all, 54 and 55, right? For illustration 54 and 55. And if you think that I need to discuss these illustrations, let me know. I'll solve them. I'll give you the video solution. So on the basis of this